Live food is live organism produced in nature and considered as living nutritious capsule as they contain all essential nutrients. Live feeds are an important basic diet for newly hatched fish, as they still have an incomplete digestive system and are lacking in enzymes. In this video, we are focusing on the method of culturing live feed such as microalgae, bloodworm, rotifer, daphnia, and moina.
Microalgae culture. Microalgae, known as microphyte, are a tiny algae that primarily inhabit the water column and sediment in the freshwater and marine ecosystem. They can be classified as eukaryotic microorganism or prokaryotic cyanobacteria, blue-green algae, with more than 25,000 species already isolated and identified. Microalgae is good for fish larvae because it readily digests, have a rapid growth rate and appropriate cell size for ingestion. For the method of microalgae culture, there are some materials that need to be prepared for this culture, which is clear container, purified water, nutrient powder, and spirulina. First of all, add 20 grams of nutrient powder to 900 ml of purified water. Stir well until it dissolves completely. Then, add both of nutrient solution and spirulina into the container. After that, cover the container with a mesh and secure it with a rubber. Next, place the container under bright sunny spot to make sure that all the filaments are exposed to light. Stir the solution once a day. The temperature of the solution should aim around 75 degrees Celsius. As the algae start to grow, the water becomes greener and opaque. It means that the algae can be used to feed the larvae. After 8 to 10 days, the algae can be transferred to another container in order to make more algae.
Bloodworm or Glycera is one of the best food for fish larvae. It can survive in different salinity and it can live with limited oxygen. To culture bloodworm, we need a styrofoam box, mosquito net, scoop net 1 mm mesh size, bloodworm, water, organic matter like fish manure. In the beginning, start by filling the styrofoam box with water around 15 cm. Put the bloodworm into a styrofoam box and cover the styrofoam box using the mosquito net. Following this, feed them with organic matter like fish manure until they become adult flies. Once the adult flies lay an egg in the styrofoam box, let the egg in the styrofoam box for around 5 to 10 days to begin to grow. The egg will grow to 3 stages: egg, larva, pupa, or bloodworm. At last, harvest the bloodworm using a scoop net with 1 mm mesh size. Then, rinse them under water to clean them from dirt, and it is ready to use for feeding the fish larvae. There are a few pros and cons in culturing the bloodworm, which is good as fish larva food because it is high in protein. Moreover, it saves money on fish larva food. In contrast, live bloodworm cannot store in the long term in the fridge. It also may be a contamination risk that will risk fish larva health. To conclude, bloodworm are encouraged to be given to the fish larvae only occasionally to avoid fish larvae health problem.
Rotifer is the one of the live feed that used to feed the fish larvae. Rotifer are microorganisms that live primarily in freshwater aquatic environment and can grow to 200 to 500 micrometers long. The rotifer name is taken from the Latin word that's meaning for the wheelbarrow. Rotifer have a unique crown of cilia around their mouth that allow them to create a vortex current that support in the capture of food. The rotifer's distinctive food and toe allow it to stick to surface and move in controlled manner. The advantage of using rotifer as a live food are their size was small and fish larvae can ingest it. It also gives a fish larvae adequate of nutrient. For the procedure of rotifer culture, first the material that used are microalgae and rotifer. Then put 3 gallons of fresh seawater into the pail and then put the rotifer inside the pail. After that, put microalgae into the culture. The microalgae are given to the rotifer as food for those organisms to live. Place the aerosol into the culture for the aeration of the rotifer. If the culture turns into normal water color, add the microalgae into it to keep their condition. It takes 7 days for the rotifer to be ready to harvest. To harvest them, 52 micron strainer were used to strain the algae from the rotifer. And lastly, the rotifer was separated and ready to use. Do the kind of the same step after culture to maintain the rotifers.
The live feed for fish larvae is Daphnia magna. Daphnia are small freshwater cladostron crustaceans commonly called water fleas. This common name is the result not only of their size, but their short, jerky hopping movement in water. Daphnia is the best natural feed for tropical fry fish and ornamental fish like guppies. The advantages of using Daphnia for aquaculture are its low cost and convenient to culture. However, Daphnia is sensitive to contaminants. Therefore, to culture Daphnia, there are several things to prepare. First thing first, purchase Daphnia capsule of eggs before preparing the chlorinated water into glasses container to observe Daphnia easily. Install a sponge filter to get large bubbles to break up the surface area and oxygenate the water, owing to the fact that small bubbles from air stone can get under the carapace of the Daphnia causing biocene problem. Set the air setting to the lowest to keep the water relatively calm. Other parameters such as water temperature should be between 18 to 22 degrees Celsius and pH level should be between 6.5 to 8.5 for an optimum growth. Once finishing setting up the habitat, the capsule of eggs is put in the container, then wait for 48 to 72 hours for the eggs to hatch. Following the hatching process, feed the Daphnia a mixture of yeast and spirulina powder sparingly. Once the culture thrives, harvest Daphnia using a brine shrimp net or reusable coffee filter.
Last but not least, Moina culture. The genus was first described by W. Baird in 1850. Moina microcopa is used as a live food for finfish, crustaceans, teleosts, and marine fish culture. Moina appears in high concentration in ponds, lakes, and slow-moving streams. They feed on various groups of bacteria, yeast, phytoplankton, and detritus, which is decaying organic matter. However, it is crucial in determining feeding rate, as Moina can quickly grow too large to be eaten. If these larger Moina become too dense, their hopping movement can serve to harass and potentially damage the fry. In culturing Moina, an air pump is needed to give aeration, but don't use bubble stone, as the fine bubbles kills the Moina. The optimum water temperature for Moina is between 24 degrees Celsius to 31 degrees Celsius. They have high temperature tolerance. Moina can be produced either in combination with their food or as separate cultures. For separate culture, the phytoplankton tank is positioned so that it can be drained into the Moina culture tank. Production from separate cultures has this advantage of requiring additional space for the cultivation of phytoplankton. However, there are advantages of separate cultures, such as less chance of contamination, greater control, and more consistent yield.
Ultimately, microalgae, bloodworm, rotifer, Daphnia and Moina culture was to provide protein source to fish larvae by using natural resources. Additionally, live food attract the larvae's attention to it. This culture activity was to provide the right size of food for larvae because larvae mouth size are smaller to be able to eat pellet food.